In 2021, question 5, we have two spheres, A and B, one of mass 4m with speed u, and the other one with mass m and speed u, going in opposite directions. So we set up our table for A and B, and put our masses in, 4m and m. We can say A is moving in the positive I direction, so plus u, and B is moving in the negative I direction, minus u. So that's before, and their masses, and we'll always call their speeds afterwards P and Q. So conservation of momentum, 4m times u minus m times u is equal to 4m times P plus m times Q. So dividing by m and simplifying, we're going to get 4P plus Q is equal to 3u. Newton's law of restitution, we're going to have P minus Q over u minus u, or 2u, equals minus e. So P minus Q is equal to minus 2ue, or eu, whichever way you choose to write it. We can bring the 4P plus Q up. 4P plus Q equals 3u. So we end up with 5P is equal to 3u minus 2ue, which we'll factor out the u in a minute. P is equal to 3u over 5 minus 2ue over 5. And Q from this equation here, Q is equal to 3u minus 4P. So Q is going to be 3u minus 4 times this guy. So the terms will change signs. So that's 12u over 5, 4 of them, 12u over 5. And we have plus 4 times 2 is 8, so plus 8ue over 5. So simplifying this, 15u over 5 minus 12u over 5 is 3u over 5 plus 8ue. And if we factor out the u and the 3 over 5, we can factor out just u and the 5. So we have u over 5 times 3 plus 8e for this one. And over here, if we factor out our u over 5, we get u over 5 times 3 minus 2e. So we have P and we have Q in terms of u and e, which is what we were asked for in part 1, and then the magnitude of the impulse on B due to the collision is t. Show that t is between these two values. So magnitude of impulse, well, we know that impulse is mv minus mu, and the speed of B was m, so we just says m times the speed beforehand, which was minus u, sorry, the speed at the end, m times the speed at the end, which is q, m times u over 5 by 3 plus 8e. And we have minus m times minus u, which will become plus mu, the speed beforehand, just double checking here, it was minus u. So simplifying this, we're going to get 3mu over 5 plus 8mu over 5, mu e over 5 plus mu. So that's going to give me the mu's. We've 3/5 and we've a full mu, so that's 8/5, 8mu over 5 plus 8mue over 5. So if we factor out 8mu over 5, we'll be left with 1 plus e. And what do we know about e? Well, we know e is between 0 and 1. So we have a max value here and a min. The min value is when e is equal to 0. So we're just going to get 8mu over 5 times 1. So just 8mu over 5. And the max value is when e is equal to 1. And we get 8mu over 5 times 1 plus 1. So we're going to get 16mu. Just leave that there. 16mu over 5. So we can say that t, the impulse, has to be between these two values. 16 mu is bigger, 16 mu over 5, and 8 mu over 5. Now, let's go back and look at the question. Show that it's between 8 mu over 5 and 16 mu over 5, which we've shown. So nice easy start to question 5 in 2021.